Lesson 8.4 is about graphing quadratics that are in vertex form. So what vertex form means is this new format. So f of x equals a, and then in parentheses, x minus h squared plus k. So just real quick rundown. If we were to follow order of operations, I would subtract by h, then I would square, then I would multiply by the a value, then I would add k at the end. So if I'm following order of operations, that's the order things happen in if I ever want to plug in a value. All right, but then the a, h, and k do specific things. A is supposed to be the vertical stretch or shrink. A can also be the reflection. So A really has two options. Depending on if it's positive or negative, it can actually cause a reflection too. That's the same as everything else in this unit so far. A has always been the stretch or shrink. H is a horizontal, a left or right shift. So that's left or right. And then K is a vertical shift, up or down. So this is the role of each of the letters in our new equation format. So vertex form, the idea is that the vertex is always going to be at the point h comma k. So if you think about it, horizontal shift, left or right, that's how much the x value is affected by the h. Vertical shift, up or down. So basically what we're doing is we're taking our vertex and moving it left or right a certain amount, and then up or down a certain amount, so it ends up at h comma k. A will change the shape and make it taller and skinnier, or flatter and wider, but that has nothing to do with the vertex. So let's actually write a list of all of the different options here. So the a value, all of the things a can do. I'm going to write some example equations here. So a is 2 in this first equation, and a is 1/2 in this equation. I don't have anything in the parentheses, so there's no h value going on here. And I don't have anything added afterwards, so there's no k value. Just something multiplied in front. So the 2x squared is a stretch by a factor of 2. Stretch by 2. The 1/2 x is a shrink by a half. So this one's going to be taller. This one's going to be flatter. So those are two options. The other two options are negative 2x squared and negative 1/2 x squared. So these are going to be the same descriptions. So this is going to be a stretch, but it's also going to be a reflection. So when you see a negative a value, it's always going to be a vertical reflection. So it's going to flip upside down. This is a shrink and reflection. So those are all the options for the a value. You can do these four things: stretch, shrink, stretch and reflection, shrink and reflection. Shrink happens when you have a fraction multiplied. Stretch happens when you have a number bigger than 1. Reflection happens when you have a negative. So those are all the situations for A. For H, we have two possibilities, depending on if we're subtracting or adding in the parentheses. One important thing is I need you to look up here, x minus h. The minus sign means that whatever you see in here is the opposite. Even though it's x minus 2, h is a positive 2. This x plus 2, h is a negative 2. How does that work? Well, you see the minus sign? So for that minus to turn into a plus, it had to be minus a negative number. So hopefully that makes sense to us. But this is the one weird thing, is the stuff that happens inside the parentheses with x actually does the opposite work you expect. So the minus 2, normally we think minus is left, but because the h value is positive, the h value is what actually makes sense. This is right 2, shift right 2. You'd expect the minus to go left, but it actually goes to the right. And so plus 2 is left, shift left 2. This is the only one that's counterintuitive. All right. The way I want you to remember that is by looking at the equation. The minus in the equation says it's going to do the opposite of what you actually see there. So a minus 2 means h is actually a positive 2. A plus 2 means h is a negative 2. So again, a little counterintuitive, but just one thing to remember. Finally, the k values. The k values are pretty straightforward. They do mean what you expect them to mean. Plus 2 is a shift up 2. And minus 2 is a shift down 2. All right, so k makes a lot more sense. There's not a lot of explanation I have to do here. Instead, we're going to jump on into doing a couple of graphs. So now you're really going to see the beauty of vertex form. I don't actually have to make a table of values. It's just really nice. I'm going to start by listing out my a, h, and k numbers. And then remember, my vertex is going to be h comma k. So my a value is 3. My h value is negative 1, because it would have to be x minus negative 1 to get x plus 1. And then k is 0. So my vertex is at negative 1 comma 0, h comma k. All right, so I'm going to plot a point there, negative 1 comma 0. Maybe I should use the other color for that, so it stands out more on the graph. And then after that, the stretch comes into play. This is where we write down our parent function again. The a value is going to stretch what the parent function normally does. So the parent function, when it goes left and right, usually does plus 1. So ours is going to go up 3. Ours is plus 3. 3 times as much. So I'm going to go over 1 and up 3 instead of up 1. It's kind of how we filled out our table before. We could do a table of values, but... And then this is up 3. Ours is 3 times as much because of the stretch, so plus 9. All right, now plus 9 is going to go off our graph, so it would have to be at 12. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 if we guess. So probably about there. A stretch of 3 is a pretty good stretch, so it's going to get really steep. So that's my graph. Didn't even have to write a table of values. I just have to follow my parent function with my stretch, and then use my h and my k value with my vertex. That's really all it takes to graph these. So we'll do a couple more. Okay, next equation. Once again, I'm going to start with my a, h, and k values. This tells me everything I need to know to graph my graph. So my a value here, there's nothing in front of the parentheses. That's just going to be a 1. When you need to pretend there's a number multiplied somewhere, the number that doesn't change anything is a 1. should be used to that idea by this point of the year. H is a -1 again, minus -1. Remember, it's opposite of what you expect for that H value. And then K is -7. So my vertex, H comma K, -1 comma -7. All right, -1 comma 1, 2, 3, 4, 5, 6, 7, -7. Then we'll follow our normal parent function. 4, 1, 0, 1, 4. And since we have no stretch, we actually follow the parent function exactly. So when I go over 1, I go up 1, just like the parent function would. And then when I go over another 1, then I go up 3, just like the parent function would. So this one over, and then 1, 2, 3. So this one has no stretch. It's going to be nowhere near as tall as the last one was. Probably could have gotten another couple points on there since we started so low, but stretch of 1, shift left 1, shift down 7. So I guess stretch of 1, I could just say no stretch because there was no actual change. But let's do one more where we have all 3. All right, once again, let's start with our A, H, and K numbers. See how our graph should transform. The A value here is 1/2. We're going to have a shrink this time. The H value is 2. The K value is -4. So my vertex is going to be H comma K, 2 comma -4. So I can plot that point straight away. 1, 2, 1, 2, 3, 4, right 2, down 4. All right, now I got a stretch of 1/2. So I'd go over +1 instead. Mine does +1/2. So ours isn't going to go up as much. Over 1, up 1/2. So barely at all. Then over 3, half of 3 is +1.5. So I'm going to go over 1 more and then go up 1.5. So now I should be at the 2 line. And you know what? We have plenty of space, so let's do one more. It would normally be 9. 0 squared, 1 squared, 2 squared, 3 squared. So the parent graph goes up 5 here. Half of 5 is 2.5. So I'm going to go up 2.5 notches. And we'll make this our last point. So over 1, up 2.5, I should end up at the positive 1/2 point. And so we'll see it's a little bit flatter and wider than the last one. It rounds out a little more at the bottom and all that. So really no calculating to do, unless you count cutting a number in half calculating, but vertex form is really nice for graphing. So if we know what our parent function is supposed to look like, vertex form applies to everything, not just quadratics. So at some point we'll get to take a look at how that affects other things like exponential functions and linear functions, but that's the gist of 8.4.